Hello everyone, good morning. Welcome to this lecture on context-free grammar in natural language processing. In this lecture, we are going to discuss what is context-free grammar and what are its applications, how it is used in NLP. So first, let's just see the definition of context-free grammar. Context-free grammar describes a set of production rules that are used to describe uh, natural language or programming language in some form. So we use a set of production rules mm, that consist of uh, set of terminal symbols or non-terminals and which are used to generate the terminals through a set of production rules. And we can use CFGs, natural language processing, natural language generation, and text understanding. So it is used to analyze the syntactic structure of a sentence. So we'll see how to rewrite or replace a particular symbol applying a rule, production rule. And this language is called context-free because the left-hand side non-terminal is a single non-terminal symbol and it is independent of the context. So that's why we say this is a context-free grammar. And let us now see the formal definition of context-free grammar. It consists of four elements. We call this as a four tuple. So the first one is uh, V. It is representing a set of non-terminal symbols. These are variables which are symbols that can be replaced by other terminal symbols. And then we have summation that denotes a set of terminal symbols. These are all mostly small case letters and small letters or symbols of the language. It can be representing a word in a sentence or a character in a sentence. And then we have R to denote a set of production rules. Each rule defines how a non-terminal can be replaced or rewritten with a combination of terminals and non-terminals. So, and then we have a start symbol, yes. So that's a special non-terminal symbol. We start with this start symbol to derive a meaningful form uh, of production that describes a particular sentence. So the ultimate aim is to generate a text or pass through the sentences to understand the text. And in this example, we can see we have several terminal symbols and non-terminal symbols as well. So S is for start symbol, NP is for noun phrase, VB for verb phrase, then PP for prepositional phrase. Then we have verb, preposition, P for preposition, N for noun, DT for determinant that denotes articles A and B and all. Then we have adjective. Terminal symbols are words present in the sentence. And the first rule, yes, derives NP, VP, denotes the actual sentence. So the given sentence consists of noun phrase and verb phrase that forms a sentence. And then here NP derives by substituting the determinant and noun. For example, the cat. And then VP is defined by verb and noun phrase. Then we have prepositional phrase. It is formed by preposition and noun phrase. Here we can be substituted with saw, the word saw, and then P can be preposition can be substituted with, and then noun can be substituted with a cat, dog, man, and all. And determinant A, B, adjective big or small. So we can substitute any of this word, and then S is for start symbol. Now let us consider one sentence from which we'll see how to apply these production rules to generate a sentence. So we have three sentences. The first sentence is I saw the cat. The second one is I saw that dog. The third one is I saw the man with a telescope. Now let us discuss how to apply this context-free grammar to work with this sentence. So we are going to apply a derivation process to generate a string that represents the sentence, and we have to start with a start symbol, and then we will apply the production rules to derive further. Okay, so we are going to repeat this process, applying the production rules until we get the target sentence. So first we start with the starting symbol S. We derive NP, and NP here substituted with the first word I, and then the VP verb phrase is substituted with verb and noun phrase. Here verb is rewritten by the word saw, and NP is rewritten by the determinant and noun. So determinant is substituted with the, and the noun is denoting the word cat in the sentence. So finally, the string is representing the sentence I saw the cat. Okay, this is a way to apply a set of production rules, starting with the start symbol, and then we generate the target sentence. Now let us see what are the parsing techniques we have that can be parsing, how to solve the problems, parsing problems using CFG. So parsing is basically the process of analyzing a sentence to determine the syntactic structure of a sentence based on grammatical rules, based on a set of grammatical rules. So this parser determines the syntactic structures which will help the natural language processing system to understand the language better for generating target sentence. So we have two types of parsing: top-down parsing and bottom-up parsing. In top-down parsing, we start with the start symbol yes, and then we apply the matching rules. We try to match the sentence to the grammar rule by expanding non-terminals, and finally we try to get a valid sentence. So we repeatedly apply the process of matching the sentence to the grammatical rules by expanding non-terminals until we get the target sentence. In bottom-up parsing, we process from the input string. We start the process from the input string. The input strings are usually the words of the sentence. We work from the uh, bottom to the start symbol. So the process will be repeated until we build a complete parse tree, starting from the leaves and going up to the root. The root will be the start symbol. Applications of CFG can be in the field of natural language generation, like text generation, and then analyzing the syntax to understand the grammars and meaning behind words, so that the interpretation of data can be improved much better. And then we also have noun phrases, verb and prepositional phrases, etc. So these grammatical components can be analyzed carefully to understand the natural language better. In text generation, we can see we can also apply this for translating the given sentence into the target form, like English to Tamil or Hindi to Tamil, like that. And we can also resolve ambiguity by constructing several parse tree for a given sentence. We can parse the parse tree to understand the purpose of the word or the meaning of the word by adding annotations or tags to it. So we can identify ambiguities that can be resolved at the uh, earliest stage. For example, we have the sentence "I saw the man with the telescope." So this can be interpreted with a different meaning. So it may cause a confusion like whether the phrase "with the telescope" modifies the man or the verb "saw." So this kind of confusion can be avoided. And in machine translation, it helps the natural language processing systems to parse the sentence and then translate the sentence to a target form. It ensures that the grammatical rules are followed to construct the target sentence. In parts of speech tagging, we can identify the role of word in a sentence, the role of noun, verb in a sentence, and it helps the system to improve the accuracy of tagging to improve the text processing. And there are certain limitations in using this CFG for natural language processing. So eh, it is difficult to capture all natural language syntax. For example, we have the sentence John and Mary went to the store, and this kind of coordination between peoples cannot be captured by the systems, and it is difficult to apply this grammar to form linguistic constructs that deals with recursion and agreement between subject and verb. So these are difficult to model in this CFGs when we work with the natural language processing. And as I already mentioned, ambiguity is another problem. It has to be resolved carefully. A sentence may have multiple meanings and multiple paucities can be there, so we have to resolve this ambiguity problem. Then there is complexity present in the text. The number of rules needed to capture all syntactic nuances may increase dramatically, so it may make the grammar uh, difficult to manage. So the system should be designed in such a way that it handles this complexity properly. Then we have some extensions to context-free grammar. We have attributed grammars. Attribute grammars usually adds additional symbols, attributes. So these are all non-terminals. We can add extra information to non-terminals, which helps the system to resolve ambiguities. And also it captures complex linguistic phenomena. And dependency grammar is another extension to CFG. This is widely used to capture the relationship between words rather than uh, utilizing the hierarchical structure. So it forms a particular kind of representation to capture the relationship, like a network-like structure or a graphical structure to model the relationships between words. Then we also have lexicalized context-free grammars. This includes lexical information, the pros and rules, which will help the system to capture the role of individual words to improve the accuracy of the text processing systems. So that's all, guys, in this lecture. So in this lecture, you have learned what is context-free grammar, how to generate grammar rules to represent the sentences, and from the given sentence, how to generate the target sentence, or how to make the system understand the target sentence. You have understood all those things. Then applications of CFG and how to apply CFG to solve the problems. All these things you have understood in this lecture.